So welcome to this video lecture of digital image processing by by the topic of histogram processing. So we are going to see the content of histogram processing, histogram equalization, histogram matching, and local histogram processing with the help of image enhancement. Histogram means definition of histogram is histogram plots how much times the frequency of each intensity value in an image occurs. For example, in your left hand side of an image will have a distinct gray levels of 8 bits, and your right hand side you have how many times the frequency has been occurred, the gray level has occurred. So from this count we can identify how the histograms are going to be processing. So this is a real time image of an histograms of a screen, so it is not viewable properly, so hence we are going to avoid by taking their overexplored pictures. Also easier to detect types of processing previously applied to image. So see here, so this is one of the example we are going to consider with intensity values. It starts from intensity value can be marked as L is equal to 16. So you are going to take it as 0 from 15. So your HI will be your intensity, histogram intensities. So it starts from 0. So 0 means 0. 1 will have 2, value of 2, and 2 will have 10, 3 will be 0, 4 0, 5 0, 6 will be having value of 5, like that each and every intensity values has been changed according to the picture. So there is no indication of localization of pixels. So for especially we have an highest priority, that is highest level of pixels will be taken into account. So 10 pixels will be marked as the value of 2. So L is equal to 16. 10 pixels have intensity value is equal to 2. So this is an diagrammatic representation of an histogram. This is one of 64 cross 64. So there is different images having a same histogram. There will be three images having same histogram values. So half of their first one will have half of the pixels are gray and half will be white. So in that meaning is that same histogram is equal to same statistics. Then its distribution of intensities could be different. So we can reconstruct image from histogram. So according to the value of intensity value, we can change your values. So histogram from a grayscale with their intensity value of ranges from I of x comma y that belongs to 0 comma L minus 1 would contain exactly L entries. So it have 8 bit of grayscale images. So L is equal to 2 power 8, that is 256 levels. So each histogram entry is defined as h of I. So h of I is nothing but number of pixels with the intensity of I for all 0 less than or equal to I less than L. So h of 255, that is 0 to 256, so totally it is 256, so 0 to 255, number of pixels with intensity level of 255. So image contrast is nothing but a contrast of grayscale image identifies, that is indicates how easily object in their image can be distinguished. So it will be two levels. One is high contrast level, another one is low contrast level. So high contrast level means your intensity value will be high. Many distant values will be there. So low contrast level means only few intensity values will be available. Histogram and image contrast. So together we have low contrast, normal contrast, and high contrast. Low contrast means the image intensity values will be very less here. Normal means it will be starting from 0 to 255. So all the values will be taken into account. For intensity value will be taken into account. For high means it is starting from 0 to 255. Whole range will be covered. So that will be having a high intensity value. So moving to the, we have already seen what is histogram. Histogram is nothing but the intensity value, that is a gray level. The intensity values will be calculated as any in histogram. So histogram processing, while processing this one, we are need of histogram of digital image of F with the intensity value 0 comma L minus 1 is a discrete function, means h of rk is equal to nk, where rk is their kth intensity value and nk will be the number of pixels in frequency f with the intensity value of rk. Normalizing the histogram is a common practice. We are going to divide the component by the total number of pixels in the image. Assuming that M and N or the images, that is row and column, with which this yields with their P of R of K is equal to Nk divided by Mn, where we need to find the occurrence of your probability. So that will be taken into account. So occurrence of your probability level, that will be denoted by Rk in an image. So um, summation of P of Rk is equal to 1. So where it is used in where we are going to use your histogram processing in your image enhancement, image statistics, image compression, and image segmentation. So we used to calculate by simply by using your software. You can enable your software calculate your histogram processing, and it is very economic, as well as hardware implementation is also very simple. Then popular tool we are going to use in the real time image processing. So you can use your MATLAB to find it out, and you can use your real time image processing tool also. So a plot of this function for all their k provides a global description of their appearance of an image. So it gives the useful information about your contrast enhancement. So there are basically image types can be corresponding to an histogram. It has been divided into 4 types. One is dark, another one is light, another one is low contrast, another one is high contrast. So histograms are commonly viewed in the plot of h of r of k is equal to nk by using your binary, or it can be a discrete function versus rk. Then we are going to find out the probability. So probability of rk is equal to nk slash of mn, that versus rk. So this will be the diagram, histogram diagram. So here first image will be a histogram of an dark image. So histogram of dark image represents the image is said to be darkened. So we are going to we note in the dark image that the components of their histograms are concentrated on your low, that is dark side of the intensity scale. Similarly, the component of their histogram of their light images is biased towards their high side of their scale. An image with a low contrast has here a narrow histogram located typically towards the middle of the intensity scale. So for their monochrome images, this implies to be dull, then washed out gray look. So finally, we see that the components of their scale, and further that the distribution of their pixel is too far from their uniform. So with very few of vertical lines being much higher than the others. So here we are going to find it out dark images starting from 0 itself. So in your light histogram of a light images means that will be from the middle to end of 255. But in low contrast, it will be available in the middle of the page. And if you are having high contrast, means the brightness level will be equal. So moving to your histogram equalization. Histogram equalization is the process of increasing the contrast of an image by spreading their histogram out of the approximated uniformly distributed. The gray level of these images has been subjected to the histogram equalization can be spreaded. Uh, Always it will reach the white images. So this will increases the dynamic ranges produces by the increase in the contrast. So for these images with low cost, histogram equalization has been adverse effect of increasing visual grainness. So there is a dynamic range. So dynamic range is nothing but depending upon the pixel size, the number of in distant pixels in the image. So it can mean high dynamic range. Higher dynamic range, the brightness level will be increased, and the darkness will be in a single image. So this will be dynamic range example. So first one will have hold the dark images, and this will be intensity levels has been marked there, and finally the ranges will be find it out by using your dynamic ranges. So histogram equalization is nothing but it is viewed by the random variable between the interval of 0 to L minus 1. So the probability levels has been identified with the help of your probability density function of PDF of random variables r comma s. If you are going to use r comma s as a random variable, p of r and p of s will be taken into account for your calculation of uniform independently form of your PDF. PDF is nothing but probability density function. So first in your diagram represents the arbitrary of your PDF. Then second one represent the uniform PDF levels of same intensity levels. Histogram equalization can be given as S is equal to T of R, where T between the intervals of 0 less than or equal to R less than or equal to L minus 1, where T of R represents the monotomally increased function in their interval of 0 less than or equal to R less than or equal to L minus 1. And it can be available between 0 to t minus t of r less than or equal to L minus 1, or 0 less than or equal to r minus L minus 1. So this is monotonically increasing function from 1 to 1 mapping both in both ways. Figure A represents monotonically increasing function, shows how the multiple ways can be mapped in a single value. Histogram equalization can be continuous as well as differentiable. So P of S of S ds is equal to P of R of R into dr. So it is most strictly monotonically increasing function of their interval 0 less than or equal to R less than or is equal to L minus 1. So in a histogram equalization, we are going to find it S is equal to T of R, that is L minus 1 integral 0 to R into P of R into W into dW. So it can be ds divided by dr is equal to T of R divided by dr, that is equal to L minus 1 into d divided by dr integral 0 to R into P of R W dW. So the value will be L minus 1 into P of R. So suppose we are going to have a continuous intensity values in an image for the PDF value, means your a transformation function will be like this. P of R is equal to 2R divided by L minus 1 the whole square between the intervals of 0 less than or equal to R less than or equal to L minus 1, or 0 otherwise. So in a continuous cases and discrete cases, this will be the values. So S is equal to, for a continuous cases, S is equal to T of R is equal to L minus 1, 0 less to R, P of R into W into dW, we have find it out. For discrete value, L minus 1 into summation J is equal to 0 to K, Nj divided by Nm, that is equal to L minus 1 into Mn, that is summation J is equal to 0 to K and N of J. So these are the examples. That is, suppose if you are going to have 3 bits of images in a time, that will be having 64 into 64 pixels. The intensity value will be taken as a calculation in your tabular column. So this function, that is transformation function, will be taken into account. So you can take RK, then we will calculate NK by having your RK, then P of R of RK is equal to NK divided by NM. So from that we can find it out whether it is continuous function or it can be discrete function depending upon the values of S0 till S7. So then we can mark it down the transformation function here. So intensity values can be marked here, and the equalization function also calculated. His histogram has also calculated. Thank you.